Welcome back to our customer facing test automation chapter of the strategies book. It occurs to me that if you watch all these videos, you could get some of the powerful ideas from the book, but you wouldn't really know in detail how to implement them. And you might get some percentage, but I'm really not worried because the goal here is for you to say, oh, Matt did this in 5 minutes. Imagine what's in the book. And I think that's fair. Speaking of which, let's talk about customer facing tests today. Customer facing test tooling. Now, there's an old idea about maturity that you've reached maturity when you've gotten away from black and white thinking and you understand that you can have two competing ideas in your mind at the same time. Hegel gave a fancy name for this, the Hegelian synthesis of thesis and antithesis. This, the idea and its opposite come together to make some sort of, we've got to get there on time, we're late, but there's a speed limit. How do we resolve those forces? And in software test tooling at the customer level, there's two. One is this idea that automation is an inherent good and we should write code to do things so that humans don't have to do it. Another is that code driving a user interface, the user interface isn't designed to be done by a computer. It's going to be brittle, it's going to be slow, it's going to be hard to maintain, it's going to give us false errors when there are changes. We talked about that last time. It's going to give us false successes because unless it's not checking anything, and if it checks everything, it's going to give us errors all the time. It's very difficult. Explaining that can be challenging. The best example I have is there was someone at a performance conference that I went to years and years ago, and they had worked for Google and in performance and load, and their bosses just wanted run a script every day, and if it's above a certain benchmark, that's a problem, and escalated automatically with an email. This is pass-fail continuous integration script. This doesn't work like that because what you really do with performance testing is you run it and you see where the peaks and valleys are and say, that's really interesting. It's on search. Maybe that's a bad example for Google, but profile view or something. And then let's bang on just profile view now. Let's crank that up to 11 and see what happens when we do just that with our. And is that a problem? Oh, it is a problem. Okay, so we noticed there was a problem with profile view. We banged on it. We got it to be a problem. Now we have to do some modeling to say how is this going to scale? What's it going to cost us with the hardware and the clusters and that? And at that level, it's mostly like, is this trending toward a problem? It's going to be trending more than overnight this went from just fine to a problem. And human beings are, you can't really write, we don't have AI for that right now. We certainly didn't then. So what the computer does isn't what the human does. But we do think that there is some value most of the time in looking at how we drive it. So we have worked in domains where this is very useful and valuable. Michael and I were both at Social Text. Social Text had the same test automation framework in place for a decade. He came in later and was part of eventually when the technologies changed, they did a rewrite. It was open source technology that was 15 years old at that point. But we were in one of the domains where it made sense and we could explain how and techniques that we did. So let's talk about that for a minute. 3 different layers. One layer, we're going to have the identifiers. That is, when you see this on the screen, that's the name of this button, and that little blob of code might change. If you're hooking to a location on the screen, the button might actually move, or you might add some new tables. It's no longer the third div down and the third child of that third div. Now it's the fourth and it's the first child, whatever. And then all the hooks are gonna break. So what you do is you have a name like login in all caps that is defined by the programming language as a constant. And then you have a lookup table where you find the XPath or partial text match or whatever you're tying to. Now, if you're tying to text, you want to say the text appears on the screen and then hook to it and link to it. If you're doing different languages, you might need the lookup table might need 2 dimensions, because you're going to say in English it's like this, in French it's like this, in Spanish it's like that. Another thing we did at Social Text was we defined a language called ZZZ, and then everything that was internationalized transformed to ZZZ, and you'd run it, and if there were any buttons that didn't look like ZZZ, then that was a problem, and you could look at the whole screen in tooling automatically for that. Look for an element or link that isn't ZZZ, and that's a problem. Then you'd have to hook by the XPath or something else. You'd have to hook into the screen location to know what to click, because you couldn't do it by text because it all said CCC. So there's your locators. Then you have your business logic, which is your login, create an account, search, add to cart, checkout, all of the things you could click or do on a page. And there's a little bit of functionality for all of those. Check search result. And that's in code. And then at the highest level, what you might call a test case, has no if statements, has no for loops. It's understandable by a human being. It looks a lot more like English because it is just composed of those functions. Then, if something changes to the core business logic, you make the change in 15 test errors, 100 test errors. You make the change in one place, you run it again, it all passes. There's also something called high volume automated testing, where we make these tests that are little small chunks that are independent, isolated, can run on their own, clean up their own data, and you can randomize them, and you can run them in a random order, and you track what the random order was. And then when you get an error, if it's a really strange condition that consists of multiple business functions, then you can try rerunning it until you figure out what exactly is triggering that error. That was more valuable back in the days of Windows and printers. Today, we like model-based testing or model-driven testing. Harry Robinson really championed that a while back. I think we reference him. And that's where we can actually model the software. From login, you can go to the home page, you can search and get the search results, and you can get to this is a wiki page or editable web page tool, something like SharePoint, something like Confluence. Or from the home page, you can make a new page. And you can edit the page, and we could add a lot more complexity here. You can tag pages. There's a lot of things. You can add a comment. There's a lot of things you can do. But the basic idea is you model this either in code or with a tool, and it knows what is valid and what's invalid, and then it can say, at this page, I know what's valid and invalid. I'll randomly decide whether I want to choose the invalid path or the valid path. And then there's something that validates the results. So you could spin around and do random walks all the way through your application. If you're going to do high volume automated testing, we think that's the way to do it. We've done a little bit of it over the years. And that's a lot. That solves the random walks problem with the minefield problem or the dog park problem that we talked about previously. It's still not perfect in that a human being can say, well, that just doesn't look right. I'm going to test around there. But it's an improvement. And at the end of the chapter, we say everything wrote is questionable because it really depends on your domain. In a wiki, which is an editable web page, you can new web page, save web page, create links, click on them, create new web pages off of that. Constantly indexed. You could search, go to that web page, search results, see your results, tag web pages, add comment. in a wiki, those strategies can be much more successful than in certain other projects. So you want to, is this really going to work for us? We just don't want you to take our advice and run with it. But if you want to go that approach, the chapter is chock full of ideas to build a structure like we've talked about. There are low code and no code tools that do that modeling for you, where designing the tooling is more like dragging and dropping a map of the app. And we've seen that be successful in some environments, yet for the most part, I don't know that those tools are particularly mature yet. So they work when your app is simple, and when your app is complex and you've got to go validate a date or something. You've got to find a grocery product and put it in your cart. It's not going to be ready for 4 days, and the software has to know that that grocery is fresh and it's going to expire, and so this is not going to work, and get an error message. Those tools can be very challenging once you get to that level of complexity for those tools to be successful. If you're writing code, you can just hit the database directly, do an insert into the database directly. You know what the value is there, or hard code it and have known good data. And we're going to talk about that when we get to test data. Tomorrow, if all goes well, we're going to have Michael Larson talking about Michael Larson will be talking about specialized testing tomorrow, and we're trying to figure this whole series out. Really, it's not just Matt. It was a collaboration, and we want to get that collaborative feel, which we thought we had when we wrote the book, into this series. So we'll see what we can do. I'm at 11 minutes. I'm sorry. There's just a lot to talk about. I'm cutting it down. So we'll see you soon. Thanks, everybody. Bye.